So I'm gonna start this off. Hello, everyone who is here. Welcome back, or welcome to your first talk. I don't know what's going on much. Um, we have Sampson talking today. He graduated in 2010. He was the RShock winner that year. Really good friend of mine. He's gonna give his talk. Same as last time with Thomas. If you have questions, feel free to ask them at any point, but we will have a specific Q&A section at the end. I'll remind again later on, but if you're uncomfortable with speaking, but you do have a question, you can private message that to me and I'll ask it for you. And so with that, go ahead and take it away, Sam.
And please ask questions. Questions are good. You know, giving talks in person is cool because you can kind of like vibe off with the audience and, you know, interject. People can interject and stuff. It's a little bit more awkward doing it in camera in your room. But yeah, so if you have any questions about anything, please don't hesitate to ask. Yeah, so let's just get right in. I kind of had a hard time coming up with like a title for the talk. Benefits of Applied Learning was Brian's idea, which I think it's a beautiful title. Basically, what I wanted to talk about is the idea that no matter what you're working on, no matter whether you know what you're doing or whether or not you succeed or fail in a project, what really matters is putting in time and effort, and the time and effort that you put into any project is always going to be worth it. Because you learn things along the way trying to solve some problem, like maybe you learn a ton about some technology that isn't even applicable to what you thought you needed to do, but you still learned that, right? Like, so putting in effort is always worth it. Yeah. So a little bit about me. I was in 589 once upon a time back in high school. And back then I really didn't like school in general. I had for a lot of reasons, I just had a lot of disdain for academics and for the whole system, you know. But once I got into robots, I found like an outlet for all of that energy that would have been spent on school. Unfortunately, I didn't learn the lesson that school is actually worth doing until after I got out of high school. And so I went into community college, and I went to 2 different community colleges, partly because I moved, but also partly because I was so behind in all the classes that I took in high school. In high school, I think the highest math that I did was geometry. I think I got a D in that. And like my overall GPA was like 2 point something. So I went to GCC, did a ton of math, went to SMC, did all the upper math, and finally I was able to get into UCSD. Barely. I barely got into UCSD. I applied for computer science or for computer engineering. I got into neither of those majors. I got into the school as undeclared major, and I was like, you know, let's just go. Let's go to UCSD. Let's go to this school. It's a great school, and we'll transfer into the major afterwards. How hard can that be? And it turns out it's pretty hard. At UCSD, like the computer science major is so impacted that I was never able to transfer in. They ranked it by GPA while I was there, and they had a GPA cutoff of 4.0 year round. And they would like have all these charts like, oh, we have these many slots for these people, and they would just like go down the list, and everyone at that number had 4.0 GPA. And then once a year, they opened it up a little bit more, and the lowest I ever saw it got down to 3.9, and I had a 3.8 at that time. So I was just like this close, but I never got into the major. So I actually ended up doing a major in cognitive science, which is pretty related to computer science, but basically no one knows what that is. Cognitive science is a bunch of things around the question about what is thinking and what kinds of things can think. Specifically, I focused on machine learning type stuff. And I'm going to be talking a little bit about some stuff that I did with machine learning in this talk too. And so while I was doing all these different community college stuff, I had a couple internships. When I was first at SMC, I worked at Starbucks, and I was a barista for a while, and a startup next door, they were our regulars, and they would come in and they had a company Starbucks card, and they would come in, and like I just started talking to them, and I got an internship there. Just after applying, they paid me like $10 an hour, which is nothing for a software engineering internship, but I learned a ton. They were some of the best engineers I've ever worked with. They took the time to actually mentor me and teach me things. So 10 out of 10, definitely worth. If you have an opportunity, I say go for it. Then later at UCSD, I was doing really well in a class, and a professor offered me a job at a company that he was running on the side. I ended up working there for several months, and each step of the way, I took the situation I was in, and I was able to leverage that for something more. And I was able to get another internship at Visa based off of the other internships I had done in the past. And then after all that jazz, after just kind of grinding, I was able to get a job at Google. And there was nothing special about that. I just applied. They had some technical interviews, and I got in. So a little note about software engineering interviews. I know a lot of high school students who are probably in the robotics program are probably really interested in programming, really interested in getting into tech and trying to get a job in it. It's pretty competitive, and it's a cat and mouse game where so many people want to be going to these companies, and so many people keep applying, and the interviewers have to find a way to filter it. So they've basically come up with a system where these interviews are crazy hard, but fortunately you can practice it. And that's the cat and mouse aspect, is the interviews keep getting harder and harder, but the tools that people have to practice for these interviews keep getting better and better. So interviewing, I know it's a ways off for most of the high school students, but it's still relevant, I think, even if you're going for an internship, because I think they kind of phone screens for those. It's a skill in itself, and you can practice it. And being good at programming doesn't make you good at it. But being good at the interviews probably means you're good at programming, because the interviews are so hard. Some ways that I found to practice. I know for the APCS people, you guys may be a bit closer to this kind of stuff. Studying data structures and algorithms is good. Working through practice problems on websites like LeetCode and HackerRank. This is probably the most useful thing that I did when I was practicing for interviews. If you guys are at all interested in trying to get into tech, I highly recommend going to these websites and trying some practice problems, especially the APCS people, because this is good stuff. The problems are really hard, and I can't do half of the hard ranked problems, but the medium ranked problems I can usually get through. I try and get through an easy ranked problem in like 30 minutes, if I can. Yeah, you can practice in whiteboard sessions and practice the coding interview. That stuff is all good. So what do I do at Google? I'm a software engineer at Google. I've been there a year and a half now, coming up on 2 years. I work in Google Cloud, primary work on the front end, and what that means is I, kind of work on pretty pixels. When you go to websites and you see what you actually see, that's the front end. The back end is like the stuff that remembers all your data, the servers that actually calculate stuff, all that kind of stuff. That's the back end. So I mostly work on the front end, and I use technology called Angular. The specific product that I work on is called Google Cloud Shell. And it's a free product that anyone can use. You guys can use it right now if you wanted. It's always free, and what it is it's a full Linux terminal in your browser. So what that means is it's basically a virtual machine running actual Linux that has persistent storage. It has a ton of programs installed on it that you can just access anytime for free. And yeah, it has your Google credentials, and since Google Cloud has all these other fancy magical tools that you might want to use if you're a developer, Google Cloud Shell is authenticated with all that. So the use case for Cloud Shell for most people is you can go on it and you can like interact with your Google Cloud resources. So I'm going to do a quick demo of Cloud Shell so you guys kind of know what that means and what's going on. Let's not do that. Cool. Can you guys still see this? Yeah, no? Yeah? Yeah, cool. Okay, so this is Google Cloud. This is like the top level page that you would go to if you're doing Google Cloud stuff. I have a lot of notifications here because of Google specific stuff. But this is like just a dashboard. There's like a bunch of stuff that you can do. There's like all these tools like storage and whatever. And oh my God, it's so complicated. There's so many things going on. But what matters, the thing that I work on is this tiny little button up in the top right. Click on that guy and then spinning, spinning, spinning. And there you go. That's a terminal. There you go. We can interact with it. We have some files in here. Let's delete some stuff. Right, okay. And we can like create files. This is an actual, ooh, that was not what I meant to do. Create files. This is a test file. I don't know how well you guys can read that, but I'm just writing into a text file. There you go. So this little thing here, this whole bottom bar, that's what I work on. And I'm, like I said, mostly the things that you actually see is what I work on. There's a bit of complexity to it, like you can upload and download files, and I wrote all the logic for that and all the interfaces for that. And there's like when you transfer files, a cool little thing pops up. Yeah, all sorts of stuff. I also work on a lot of the testing infrastructure for the team. Yeah, does anyone have any questions about like Google Cloud or Cloud Shell before I continue? No? Anything? It's a cool product, I promise. Okay.
Hey Sam, it's Mrs. Martos.
Oh yeah.
Hey, so do you work from home or do you actually go into an office to work?
I usually work from home. I mean, usually work from the office. Right now I'm working from home. So with all the coronavirus stuff that's going on, all the offices for Google are shut down. Typically, I work in an office in San Francisco.
Okay. And so when you first hired in and they like sent you off to your office, what was that like getting all set up there?
Right, yeah. So interesting note about like my start at Google was I didn't actually start as on the team that I'm on now. I guess I could have led with what I did when I first started. I started at Google as something called a engineering resident. And an engineering resident, it's similar to the story of me getting into UCSD just barely. I just barely got into Google. And the engineering residency program was a great program. It was a rotational program where you like work on this project for a little while, then you work on that project for a little while on different teams. So when I first started, I went up to Mountain View, and that's where I was first working. I did about 2 months of training where they showed me all of this crazy proprietary Google tech that basically you would never have been able to know. Like no one uses it outside of Google because it's custom made by Google back when Google first started, and they just never changed it. They just kept improving it. So normally when you like work on software like in your classes or in open source stuff, you'll use version controlling systems like Git or Subversion, but Google doesn't do that. Google uses something called Piper, and they have one giant software repository for all of Google's code, all just in one giant mountain instead of having a bunch of different small code repositories. So they gave me about 2 months to try and like learn this technology, that technology, how to write code at Google, how to do this, how to do that. I think it was really, really useful. It was really, really helpful to get a head start because otherwise you just kind of have to pick that stuff up.
Thank you.
Any other questions about Google or Google Cloud or anything else?
How much is it like the movie?
The internship movie?
Yes.
I still haven't seen it. I've been told to see it several times and I never saw it. I just haven't seen it. The premise is they like walk on and sneak in with a bunch of interns, right? I'm not
Yes.
exactly sure what happens in the movie, so I don't really know. They give us free food when I'm in the office, if that
Nice.
is a plot point. That part's good. They give you free breakfast, lunch, and dinner, but it's at like specific times. So like you have to come into the office early and you have to leave the office late if you want to get all three. So they get their money's worth out of that.
Wow.
Yeah, you have to come in, I think at like 8 is when breakfast is, and dinner doesn't start till like 6:30. So if you're doing all three, you're having a long day. Cool, okay. Well, you guys can also ask me more about Google or anything else at the end too, so I'll just keep moving along. So what makes working on this product kind of interesting or challenging? So like I said, I just kind of work on the pretty pixel side or the testing side, but the product itself is kind of in a weird space because it's part of Google Cloud. It's an integral part of Cloud's offerings, but it can't really take advantage of the whole infrastructure of Google Cloud or cloud-based applications in general. So in the cloud, as a concept, you have a ton of different machines and they have different features, different RAM, different processing power, different whatever. There's tons of them out there. And then you have some software that kind of orchestrates all those different machines. You have a load balancer that tells incoming traffic, okay, you're going to actually go to this machine and you're going to go to that machine, and maybe this machine is down, so we won't redirect anyone to that machine. But in Cloud Shell, we don't have a load balancer. We don't have multiple machines. We have actual VMs running in GCP that the user has to connect to directly. So if that machine is in a bad state, then the user sees that. So we do a lot of work to actually orchestrate these VMs ourselves, and we have our own tech stack for doing that. And the front end has to actually coordinate that too. So when the user logs in, they have to, the front end has to provision the VM, has to start a connection to the machine, and that's a lot of complicated stuff with SSH. There's actually a full SSH implementation in the browser that generates SSH keys and pushes them to the VM. Oh my God, it's so complicated. So it's a bit of a complicated tech stack, and it keeps things interesting. Yeah, and people expect it to just work because it's Google, right? Like you go and you type something in and it should just work. You go and you click a button and you should just get a VM. It should just work. Kind of crazy. Cool. So there's something called design document culture at Google. You may have heard of it. It's kind of public knowledge at this point. But it's kind of similar to the idea of like when you're building a robot or you're working on a project, you're going to be designing it in full. You're going to be making a proposal for what you're going to do before you write any code, before any work is done. It's kind of integral to the whole work cycle at Google. You may do some initial prototyping, some initial work just to like prove that this can be done or something like this can be done, like that this makes sense. But typically you throw that work away. You never actually build the real thing first. And then you propose it, you get feedback from other workers, and then you incorporate that into the design, and then the design itself serves as a living document. So it keeps getting updated as the project goes on, after it's been approved. So you made this design, you start working on it, and then, you realize, actually, this isn't going to work because that service is now deprecated. We need to use this other thing that is the next shiny best thing. You put that in the design doc. So anyone can go and look at this design document, and they can read it and figure out, what are they doing? Why are they doing it? Who's involved? Who has approved this? And what's the current status of this project? So I'm going to talk a little bit about a design that I wrote while working at Google on the front end. So this is a tentative project at Google. And that thing, hterm to xterm.js, what are those words? Let me go back to this guy. So this black box here, this is a terminal emulator. And a terminal emulator is basically a piece of software that makes it look like you have an actual terminal there. But it's really just HTML, CSS, and JavaScript. It's just, there's nothing special to it. You can just go and inspect it, and these are just literally HTML elements, and there's some fancy JavaScript that takes the output from the virtual machine and turns it into letters that show on the screen. And that piece of software that actually handles that whole black box is called hterm. And we want to upgrade it. We want to update it to something called xterm. And so that sounds really simple, right? Like we have a black box, we want to swap it out with another black box, easy peasy, spend an afternoon, just do it. But it turns out that in order to do this appropriately, in order to do this in like the right way, you have to actually re-architect the entire front end. You need to, reconfigure everything about everything on the entire front end in order to make this work. A little bit of time was spent as like trying to figure out how to drop in xterm for hterm, and it's technically possible, but it's just not worth the extra effort because long term you're going to be re-architecting anyways. It's like you would fit a square peg into a round hole, and then you have to like chop out the it's just crazy. You wouldn't want to do it. Just a note about the tech here. Cloud Shell's front end is an Angular app, which is another type of framework, and the front end interacts with various Google services to kind of orchestrate these virtual machines, open and maintain the SSH connection. But right now, this little black box right here, the black box is actually responsible for almost all of that for historical reasons. It's just, we kind of inherited this part of this project from a different project. And so all of this logic is handled inside of that black box, which is kind of crazy. To put it into a visual perspective, this box here is the same as that black box over there. And inside of here, there's a ton of logic, like VM initialization, SSH logic, a ton of stuff, almost everything, even transferring funds inside of that black box. And then Cloud Shell, as a front-end application, talks to that terminal iframe. It's such a weird way of doing things. It doesn't really make sense. And that's why upgrading one for the other means duplicating all of that logic all over again. What we would like is, what would make it easy is if it looked like this. If the terminal was just a piece of the user interface that was just pretty pixels, and then that would talk with other logic, maybe, and then that logic would talk to the rest of the backend. But that's not the way it is. The way it is looks like this, where things talk to the terminal and then the terminal does everything itself. So this whole work is about trying to deconstruct this whole situation, going through all of the logic, detailing everything that needs to be done, and then coming up with a proposal for, can this be done? Can xterm, work in its stead? But why do we want to do this? Why does anyone care? To improve accessibility. So I don't know if any of you out there know about screen readers, but people who can't see still use, or have limited vision, still use computers. They use something called a screen reader, and it basically reads off all the words that are on the screen. And hterm, the current technology that we use, just doesn't work with them at all. It wasn't written with that in mind. It just doesn't conform with all the right properties that would be needed to make that work. We also want to improve browser and mobile support. hterm was written as a piece of technology specifically for Chromebooks. And so it works really, really well with Google Chrome, but almost no other browsers. And it uses a lot of old tech, JavaScript and callbacks is what it uses. But Angular uses TypeScript and promises and observables. Minor detail. It's just old versus new. It just uses old stuff. And we would like to separate the concerns of the terminal and the rest of the logic. So we want to move towards that. And yeah, I can't really show you the whole design, but basically the work entailed taking apart Cloud Shell altogether, coming up with a proposal for which of these blocks are needed and which of these blocks can be migrated easily and in order for the work, like which things should be built first and then which ones can be built later. And yeah, so what I learned from working on this design project, this is another example of that kind of key takeaway that the effort that you put in matters more maybe than the outcomes, because this project hasn't even been worked on yet. And I did this design maybe a year ago now. But going through the process of kind of dissecting the whole product and how it works both on the front end and the back end, it's made me dramatically more efficient at my job. I understand how all the pieces move together and work together and where pieces of the system are just by coming up with this design. Not even having written a single line of code. Just by writing this document, I was able to be a lot more efficient at my job. You know, giving technical presentations, how to write technical documents, and learning about a system, the backend system, that I had never really interacted with before. Cool. Any questions about documents or design documents or anything like that, or no? No? All right, cool. So
Sam, sorry, I have a question.
Yeah.
How does Google keep track of all these documents then? I mean, you guys are a company with a lot of products and a lot of people. If I were to magically start at Google tomorrow, how could I look up the documentation?
That's a good question. They're literally just Google Docs. They're like literally just docs.google.com, and you can search for them. So you can search by like document title or by owner. Another thing you can do that we do internally is we have like, they're called Go links. I don't know what the analogy would be. I know like Yahoo uses Y links, but it would be like my link for mine is go/cloudshell-xterm. And so I just like know that link, and I just can share that in the chat with anyone who's interested. And then inside of like internal pages, like we'll have a website with all of our, you know, this thing, that thing, that thing. You can just add a link to it. So typically it's just with like internal websites, internal links, and then the search engine with Google Docs. Not sure it works the best. It's not particularly discoverable. Like it would be difficult for me to go and like find a design doc on a project that I don't know exists, right? Like how would I find that document? But then again, why would I want to, right? Is that kind of what you're asking?
Yeah, that was it.
Okay.
Thank you.
Cool. Anything else about writing documents before you start working, or is that too dry?
No, I think that's enough.
All right, cool. So the next project that I want to talk about is something that I did while I was at college, and I'm going to kind of breeze through this. I just kind of dumped the slides for this project. I gave this presentation at UCSD in front of a classroom full of grad students and professors, and this project was a catastrophic failure. Nothing worked, and yeah, I got an A, so it all worked out. So passive BCI for enhanced listening experience, and that is a title. So let's unpack that. BCI. BCI stands for brain-computer interface. So a brain-computer interface is some device that uses information gathered from neurological data, you know, EEG or whatever, MEG, whatever, data from the brain, information about what's happening in the human being's brain, and it allows humans to do something based on that. So that's the interface part. So there is some device is the interface to a computer that's running some software, and the brain is the thing that's controlling it. The passive part, it's a really subtle distinction, but maybe I should give an example of what a BCI is. So for people with ALS, they have progressive deterioration of motor skills, so they can't move basically. And in the extreme, they can't move at all, but they're still there. It's basically locked in. And some of them have there's different degrees of the progression of the disease, but some people can move their eyes, have pretty good control of their eyes, and so they can control computers like their wheelchair or something else with their eyes, like Stephen Hawking, but some can't even do that. And for those people, they build these BCIs, which is basically a bunch of EEG things strapped to their head, and they think really hard, like, oh, I want to go forward, or I want to go back, or up, down, whatever, and it allows them to control something using that. So that's an active BCI, where they are actively trying to do something, and they just think about it, and then it happens. And a passive BCI is kind of the opposite. The user isn't actually directly controlling anything, but it's still reading from the same data, and it's still controlling some software. So all that to say, this project is about something that I wanted to do, I was really interested in doing, and I took a class on this at UCSD, where you kind of read neurological data, and you're able to determine how sensitive people are to specific kinds of sounds, and then make their headphones sound perfect and tailored to them. Right, so a little bit of background about where this idea comes from. People have different degrees of hearing. Some people have hearing loss, but in general, everyone's hearing is slightly different. Some people can hear more bass, some people can hear more highs, some people can hear this and that. But typically when you go out and you buy headphones, you don't have anything that's custom tailored to you, right? You just buy some headphones and hopefully they sound good. Yeah, and basically the idea is to make it so that they can calibrate it automatically versus going through and getting an EQ and messing with the knobs and dials and trying to figure out what sounds exactly right for them. If you don't know how to do that, or what even a frequency response curve is, you should be able to just put these headphones on and you start listening, it maybe plays a jingle, and then all of a sudden they sound perfect. Could never sound better. That was the goal, at least. So high-level goal, create an audio system that responds to a user's neurological responsiveness to sound and calibrate itself. So I'm going to kind of breeze through these slides because there's a ton of them. I'll kind of jump through. I did some research initially on different kinds of neurological responses to sounds. I kind of landed on one that seemed really reliable, really robust, mechanistic. Basically, when you hear a sound, it automatically, very, very quickly afterwards, says 6 to 10 milliseconds, you'll be able to determine that they have heard the sound. Yeah, so what did I do to actually make this work? I wrote some software using some brain-computer interface stuff, and that's a terrible picture of me, but that's the only picture I have of this whole saga. Basically, I would play a sound, play a tone, and then record the EEG, and then try and classify whether or not a sound was actually played. I would also record EEG data without any being played. And the cool thing about this is that this ABR thing on the previous slide, the auditory brainstem response, has been really, really thoroughly researched. So where you're supposed to put the electrodes on the forehead, and what resolution you need to record at, that's all been researched really, really well. So I didn't need to worry too much about that. So basically, I would just play a tone or not, and then record some EEG data, automatically label it, and then voila, I have a data set. So this was a machine learning project. Maybe I should take a minute to explain what that means. Basically, what you need for a machine learning project is a ton of data and and labels for that data that basically says this in the input space, this data corresponds to these labels. So in this case, the labels are a sound played or a sound didn't play. So I built it with this stuff. I did a bunch of filtering. That's just super low level signal processing. And then I did some math to try and decompose the original signal after signal processing into more meaningful signals. And now I have some kind of maybe cleaner data that it has good labels to it, and I have a ton of samples. And so now I just apply some machine learning to it, right? I trained a neural network, and drum roll please, it classified very well in the training set, but not at all in the test set. And basically what that means is I didn't have enough data, and the model that I was using was too flexible. I'm sure that means nothing to most people, but this is a known problem. We were told about this, ad nauseum in all of our classes. This is very well known. If you have like only a couple hundred, I think I had 2,000 samples. If you only have very few samples for really high dimensional data, like I think these were like 2,000 numbers, something like that for each sample, you're basically only going to be able to memorize the data. You're never going to be able to understand the underlying pattern with such a flexible model. But I kept trying. I tried for weeks. I tried for weeks on this project to try and get this model to perform, and I was never able to. And so there you go. Even with lots of stuff to try and overcome the variance in this model, nothing was able to get it past basically a chance classifier. You can see it sort of trend upward above chance, but it's not really any good. So I did do some things that were kind of interesting in this project, like creating a methodology to collect this kind of data and label it automatically. For this kind of task, I don't think there was any research on doing something like that. I built a solidly overfitting classifier, and when I said this at the original presentation that I gave this for, everyone laughed. So there you go. And I learned a ton about signal processing and collecting EEG data. And I had some plans for what I would do next, but life got in the way, so I didn't do any of that. And yeah, so this slide is what I've learned since then, so a retrospective. This project was a catastrophic failure only in that I wasn't able to build the classifier that I wanted, and I wasn't able to use it for what I wanted. But interacting with all this literature and understanding how it worked and getting almost there was almost just as valuable. And interestingly, someone has actually built this product just without the neuroscience aspect. Someone built this. It's called Even H2 headphones, and they sounded okay. I think it's totally a gimmick. I was pretty stubborn with this project. I could have used a different machine learning algorithm for this that would have been much better. I should have sought out advice earlier, and I should have listened to the advice that was already given. And what I really learned was that I don't want to just struggle with this kind of approach again. So nowadays, when I work on things like this, I'm much quicker to just work with the thing that is known to work well versus kind of struggling with something that I want to work. Any questions about brain-computer interfaces?
I have a couple of questions since
Yeah.
this is what my research is on. So
yeah. Again, nothing that I did worked. So
I know. How much data would you say you actually need for this to have worked?
It depends on the model that you're using. So I think this probably could have worked with an SVM or some other kind of classification. And really, I should be trying to regress, right? Like I'm trying to do a frequency response curve, right? I'm trying to fit that curve. But like I was just trying to do step one, let's just say, did the user hear a sound? Not how sensitive were they to that sound. And so step one, let's just like, did they hear a sound? It's hard. Your question is at the core of machine learning research, right? I don't think there's a good answer to that question. The things that matter are the dimensionality of the input space, how much data you have, how good your model is at approximating the function that you care about, and how complicated the relationship is between the input space and the output space. To put it into like other words, like say your data set is images, right? And you want to classify, it's like there's a cat or there's not a cat, right? So if you have really, really high resolution images, you're going to need many, many more samples. But if you have tiny images, then you don't need as many samples, right? Because like it's a small picture, there's not as many parameters in the image. And you know, the fewer that you have, there's something called a bias variance trade-off. And that's kind of like when you get into choosing which models to use. And if you have more bias, then you can't learn as complicated functions. But if you have more variance, you get so many slides away. You get this, right? You can never actually learn the actual pattern. So it just depends on the situation. It depends on what data you're using, how complicated the function is. And for the images, like let's say for fixed resolution, for fixed number of samples, you know, the complexity of the relationship, let's pretend like your lens was dusty, like your pictures are all blurry. It might be a lot harder to tell whether there's a cat in the image now, right? Like, so then you just need more samples, and there's just nothing you can do about that. I think EEG data is really, really noisy, really, really blurry, because your skull is in the way, right?
Right.
Yeah.
Not at the store, no, not at.
Any other questions about brain-computer interfaces?
Yeah.
Okay, so you do need to go with them again because they need to check that it's okay.
Sure.
Nothing is wrong with it.
Okay. I mean, I
And
haven't
then
opened
they're gonna
anything
give you
yet.
All right.
No? Yeah?
Yeah, let's
No,
have you
no.
continue on
Okay,
and
cool.
try and finish up your presentation before more questions.
Yeah. I have one more project to talk about. I'll go quickly on this one. I tried to go quickly on the last one too, so I'll go even quicklier on this one. So this is another machine learning project, and this one does involve images now. And this one, the machine learning worked, but I never finished it. So I guess that's kind of a failure too. So let's talk about video poker. So I don't know if you guys are old enough to go to a casino, but this is what video poker looks like. I don't know if you guys are old enough to even know what poker is or have ever played poker, but poker is a card game where you kind of bet and then you get a hand and you either win or you lose. The video poker variation is like you press a button to say how much you want to bet, they deal some cards, and then you choose which cards you want to hold, and then you deal and you either win something or you lose something. These numbers at the top basically say how much you're going to win, like if you get a royal flush or a straight flush or a pair or two pairs or whatever. And yeah, each game has, for each pay scale, for each set of hands, there's like a correct decision, right? So let's say there's 4 aces on the screen. You got to hold all 4 aces because if you hold them, then you get a ton of money, basically. And if you don't hold them, then you just get like random, which is you're basically going to lose money. And each of these games that are out there, none of them are actually, like on average, you don't actually ever win, spoilers. So even if you were to play perfectly, even if you were to select the correct hand every single time, on average, if you play for long enough, it'll average out to you losing on average this much percent for these kinds of games. There are rarely some games that have like even playback or even positive playback, but it's typically only on like specific casinos and specific locations that are trying to do a promotion or whatever. But in general, you're always losing money, even if you're playing perfectly. The real ripoff is when you don't even know how to play perfectly, then you're really losing money. So basically what we want to do is we want to make a machine learning something that'll let us kind of play this game perfectly without having to think about it. So kind of framing this problem as a difficult visual task. It's difficult for humans, not because it's hard to see what's on the screen, but because it's hard to figure out which cards to hold, right? Like in this screen here, like which cards do you hold? It depends on which game. It just depends. You know, you can't even say for any given game, like I don't even know what game this is. It really depends on the exact scenario and the exact payout, which cards to hold. In one casino for the same game, for the same bet, for the same hand, it might be different for a different casino. And it's difficult for computers for an entirely different reason. the part that's easy for humans, which is seeing what's on the screen, is actually the hardest part for computers. And the easiest part is figuring out which cards to hold. You can actually just calculate, basically instantly which hand to hold. People like there's apps for this. You can download it on like the Play Store or the App Store, like video poker, whatever. It's easy to do. But figuring out which cards are actually there, what the hand is, and what the pay scale is, that's a bit harder. So that's identifying the problem. And back when I gave this talk first, I gave this talk at Google. This is the anatomy of a machine learning project in general, and it goes through the steps of identifying a problem, gathering data, training a model, and then deploying the model. So that's identifying a problem. We've identified that there's an opportunity where there's something that's hard for humans to do that could be easy for machines to do if we set things up right. So next we got to gather data in order to actually start working on this problem. And that data looks like these images that you see on the screen right now. A ton of pictures of video poker screens labeled. And that's what we're going to talk about next. So in order to gather data, I have this fancy little pain scale. This is something you'd see in a hospital. And judging from like no pain to the worst pain, we have over on the left, we have a data set class. You'd have something like you could download and the data is already labeled, and you could just like start working on a tutorial and you just, it just works. Next is, there's a ton of data out there, but there's no labels for it. Maybe you can do something with like unsupervised learning or semi-supervised learning to get around this. It's a bit more painful, but still tractable. And then the next hardest is similar to unlabeled data set exists. You can collect the data and apply the labels automatically, but collecting data can be very, very challenging depending on what you're trying to collect data for. And then the worst thing is manually labeling large data sets. And that's what I chose to do here. The next best thing is paying Amazon to label your data for you. And I did not have the money or the knowledge to do that back when I worked on this project. So all in all, when I finished, I had 444 images of the screens themselves and 11,000 cards extracted that I manually labeled. There's a lot of details on how I did this in this thing, but basically the long and short of it is that I built a pipeline, which was a server that I was running that I could upload images to that would automatically find rectangular regions in the image, automatically apply labels to them, given whatever the state of my machine learning classifier was in. And then I would go through and I'd just correct it. And so here's what I do. Capture image, extract rectangles, classify whether it's a card or not a card, classify whether it's what number it is, classify what suit it is, deduplicate in case there's, same card seen twice, and then recommend. The card extraction was a lot of low-level computer vision techniques. This is what people used to call artificial intelligence, and now this is just computer vision, and this is just like generic algorithms now. And that kind of goalpost keeps changing. So all of the steps on this flowchart is basically the exact details of how I was able to extract the cards from the screen. And each step has like parameters, tons of hyperparameters in here, like apply a blur to the grayscale image, like what radius of the blur, what type of blur, These things can be optimized and tweaked to give you, exact results. And so you kind of manually go through and you tweak these things, as opposed to machine learning where you kind of learn those things automatically. And then basically I have a ton of cards after that I was able to extract with some label applied to them. Most of them are wrong. And then I just manually went through and I built another web app, another server that would serve these images and show what they were. And it could filter by it and then, kind of just click through and say, no, that's a 2, no, that's a 4. And basically in the end, I had built these sunglasses with a Raspberry Pi Zero and a camera, and I was able to actually go to the casino and actually see what the cards were. So how I was able to do that was after I had these 11,000 cards labeled, I used some convolutional neural networks and I deployed them to that Raspberry Pi Zero. I tried some other things, but I was able to get good accuracy with what I was doing, so I didn't need to explore much further. And the testing accuracy was good. It worked really well. There's some details on the neural network architecture. And this is where I left it off. It was work in progress and it never got finished. What did I learn since then? So this worked. Basically applying those steps of identifying the problem, setting yourself up for success at the beginning and collecting the data and then trying to tweak your model after you have enough data. That it worked. I was able to actually extract cards and actually be able to see what cards were on the screen, like label them in real time. Electronics is difficult. That was probably the hardest part of this. The processing power on these small boards that you would want to use in a casino setting or on a battery pack, they're not very powerful. I had to compile TensorFlow from scratch on a Raspberry Pi Zero because no one does that. And so there was no binaries out there that you could just download. And that took a day and a half just to compile the software, a day and a half. So if it didn't work the first time, which it didn't, I would have to wait a day to see. And automating all this like card extraction and everything, that saved me a ton of time versus trying to like do these processes like one by one. Small problems can be big, yeah. There are a ton of different versions of video poker out there. I was able to get it to work for the machines that I had access to, right? But if the screens were different in a different casino, then it's just not going to work, If things are different, your model's not going to work for it. Yeah, I kind of rushed through that, but maybe you got the high level, machine learning can tell you how to play poker. Any other questions about that or anything else? That's the last slide. That's all I got.
So Sam, all of this is super interesting. Do you prefer to work in teams or individually?
Ooh, academically, I liked to work individually. At work, I like to work in teams.
And why in teams at work?
The people that I've worked with in work settings are much more invested. It's their job. I don't know why that is. But like in college, I would go into these like, high level computer science classes or math classes or whatever. People kind of just coasted a bit. I guess that kind of motivated me to not be like that. Like it would always be frustrating getting a class project and then having to do all the work. But at some point I just decided that I shouldn't have to rely on those people to get my grade. I shouldn't have to do that. But now that I'm in like a work setting, now that I've, worked at a few different places, usually people are a bit more invested. And when you have people who are knowledgeable, that care about the things that they're working on and that are invested in the project, it can be really great, especially when the people who you're working with know more than you. That's really good because they can teach you.
And at Google, are the teams sort of composed of more experienced or savvy, like, I don't want to say, at JPL we use the term graybeards is not exactly any longer the right term to be using, but identify these people who have a lot of experience that we're trying to partner with more junior people who have less experience. How do they teams at Google?
So I think it's pretty similar. I don't think we have the term graybeards, but I think they strive for a balance as well. So there's a few people on my team that have been on the team since the beginning, and they know the entire tech stack front and back. And then there's a bunch of other people who maybe know a lot about this area or a lot about that area. And now I'm one of the people who knows a lot about my area of the code. So if this guy has a question, he can come to me. If I have a question, I can go to that person. And then if we all have a question, if everyone's confused, we can go to the much more experienced person. I think they like to go for a distribution with younger, like more junior people, more inexperienced people, and more senior people for a number of reasons. I think that the more junior people, they don't have to pay as much. So if you have a bunch of worker bees that you don't have to pay as much, that's, that helps the team out, right? But it's also about like the culture of it too. If you get more people, more perspectives on the team, more diverse thought pool on the team, you overall make a better product. And over time, those people become more senior, and it kind of just, it builds on itself and it builds on itself. And they like to talk a lot about impact, right? And so the more senior you get at Google, they want to see you have more impact. And you can get more impact by working harder or being smarter at what you do, or you can have more impact by, you know, leading a team and having all these other people that you helped work on this big project. And now you have 5 people under you, and they're all working on this huge thing that would take you a year to do that they can do in 2 months, that none of them could do by themselves in 2 months. Like, it's not that they are all that smart. It's with your direction and with you writing these design documents and setting them up for success. You can kind of orchestrate the worker bees. I definitely think having a distribution of people who know a ton about what they're working on and some people who are trying to figure it out is really, really valuable, especially because it stops like that aspect of people who are in silos that kind of just, this is my thing, you know? I saw a lot of that at Visa. Visa was very much so that way. And I don't think it was productive. People would just kind of yell at each other, like I need access to this, why don't you give me access to this kind of thing. Is not productive. But having an open environment where there's a distribution is pretty helpful.
It also brings diversity of thought to the table, right? Which I think Google probably looks for more. Different types of thinking and different ways of solving problems.
Yeah, definitely. Yeah, you definitely don't want everyone who thinks the same way, because the products that you're building aren't for you, right? You don't want to just make a product that's really good for you, right? Like, if I made something that worked really, really well for me, but it didn't work really well for anyone, well then, what was the point of doing that, right? So the more kind of ways of thinking, different kinds of people, different ways of thinking, different expertise, not even just software, like not even just STEM even, at all different types of people, all different types of backgrounds are, you know, really valuable, because all that background, and it kind of ties in nicely with what I'm saying about putting in effort is always valuable. Even if it's not effort towards your career, it's still valuable. Even if it's the paintings that you're making or the music that you're writing, that still informs what you do in other things too. Gives you perspective on it.
Super cool. Thank you.
Any other questions? Machine learning or Google or how to, I don't know, go from failing. Yeah, go.
Hey, Sam, it's me again. I have a question. You may have not noticed, but I'll tell you, there are a lot of people listening who are soon going to start their first year in college. And I personally know that you had a bit of a, you know, non-typical journey for college. So from your perspective, what is some advice you would give these incoming freshmen?
Yeah, okay. So my freshman year in college was a weird one. Specifically, I was not planning on going to college, and then you convinced me that I needed to go to community college. So I guess starting there, if someone strongly recommends that you need to do, you know, this class or that kind of thing, you should probably listen to them. You know, I think that's probably good. The same kind of thing happened when I started at UCSD. I asked around, and people were saying, oh, going from semester system to quarter system, you guys aren't prepared. The pace is so much faster than semester system. It's like crazy. You can't take 4 classes, da 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 da, especially not your first quarter. And I took their advice. Like, I had been maxing out all my units at community college for the longest time. Like, I was taking 16 plus, maybe up to 20 I took at one point, units in a semester. And I was able to do it. It was fine, because you have 10 weeks, you know, to do stuff. And then I went to UCSD, and they were saying, no, you can't do that. Not your first quarter. It's not gonna work out. And I only took 3 classes my first quarter, and I was kind of worried that that wasn't going to work out. But it ended up being one of the best quarters that I had. And I took like classes that I thought were going to be easy, and classes that I thought were going to be like you know, just kind of coast through. But they were some of the best classes that I ever took too. I would say for incoming freshmen, take your time. Take your coursework seriously, but don't overload yourself. It's not a race. It's really not a race. It's a marathon. I did community college for 4 years before I got into actual like university, and you know, it's slow and steady wins the race for sure. Just being consistent and putting in the time and effort for loading yourself. Those are the best things that you can do, I think. And honestly, just like take the things that you're interested in, take the classes that you want to take, because you're going to find it a lot easier to be consistent with what you're doing than if you're taking the classes that you think everyone else wants you to take. My first year or so at GCC, I took like electronics courses and machining courses that I've never used since, but were really cool to do.
Hey Sam, when you were
Yeah.
at UCSD, did you participate in any research?
Did I participate in any research, like as a researcher or as a test subject?
Either. Specifically, I'm talking about researcher, and yeah, did you do anything like that?
So I did a few like research projects, but as far as like getting published or doing a thesis, I never did any of those. No, I had an opportunity to go and work with one of my professors and work on a research project that I was really interested in. It's actually that brain-computer interface is what I was gonna jump off from after that. I had a research proposal for that. For like, I would have tried to get a grant and then start collecting the data and build it out from there. But at the same time, I got that offer from my other professor to work for him at his company. So I took that offer instead. So I think there is an interesting thing there is like academia versus industry, and I don't know that there's a right answer. I made a decision, but I don't know if it was the right decision. I could have leaned much more heavily towards academia, leaned much more heavily towards like, okay, I want to do a master's, PhD, whatever, or go more for industry. And I kind of just went based off of the kind of work that I'd be doing and who I'd be working with. And I think it worked out, but you never know. I still think about going back and going to get a master's or a PhD. But no, I have like basically no research experience at this point.
And you basically answered my next question as well, which, maybe we can build off it more. Do you feel, you've done a lot of internships and work. Do you feel that you've had more opportunities to learn in the work environments than even just taking classes and doing projects in those classes?
I think they're kind of different. I think like the things that you learn in the class are a little bit different from the things that you learn from work. And they kind of build on each other and they help each other, but they're not the same thing. I don't even list all of the jobs that I've had on my resume anymore because there's just too many. I've had like worked at this small thing doing that, this small thing doing that, and all these different small companies that I've worked at as an intern. I basically took every opportunity that I could get so that I could pay for college and have a nice laptop. Like those are my priorities. I wanted a graphics card and a nice laptop. Like, yeah. I think the things that you learn in school are kind of like these like weird abstract tools that are really, really fascinating and really, really interesting. And they're useful in and of themselves. And then the things that you learn at work, they never feed back to that, but they build off of that. Like work ethic you can learn at work, sure, but like you're never going to learn like some crazy esoteric math algorithm, whatever. You're never going to learn calculus working as a programmer, right? Like it's not part of the job. But knowing calculus can help you as a programmer in certain situations. Definitely. Yeah. I think me personally, I think I've learned a ton about programming at both of them. I've taken every opportunity that I could to try and try and learn about the craft of programming, both in school projects, in machine learning projects, and at work. And maybe that'll kind of exemplify what I'm talking about. Like, what matters in an academic setting for your software is more the algorithm itself. Like, is your approach mathematically correct? Is it mathematically optimal? Is it the right thing, you know? And then the thing that you're doing in a class project is like, does it work? Can I give a demo on the final day when I'm supposed to show that this thing that I built for 6 weeks, does it actually work, right? Similar to like a hackathon. And then when you're in a work setting, both of those things sort of matter, but what is really, really important is how well it works for other human beings. There's a whole aspect to software that's like software as kind of like poetry. It's meant to be read and understood by humans, not just functionally correct, not just optimal in terms of its runtime or whatever, but actually a cognitive artifact in itself to be understood and used and built on by other people. And so you might do a trade-off, like you might write code that is technically a little bit slower, but it's much, much easier to be understood. So it's less likely to have errors in the future as people build off it. And having that skill down, like being really, really good at writing legible code, does not matter when you're writing a brand new algorithm in a research setting, right? When you're doing research on a new machine learning algorithm that no one's ever done before, you know, the software itself is never included in the literature. Like nobody includes their software, right? Like they include the algorithm, they include the results, but good luck on implementing it. Like I'm not going to include my software in my paper, you know? So I think the things that matter in those different environments are different. And yeah, they build on each other for sure.
Sam, did you participate in hackathons when you were going through either your community college or college?
Yeah, a ton. I love hackathons. Hackathons are really, really fun. If you guys have any opportunity to go to a hackathon, go to it. Go to it immediately. They're so fun. They give you free food. They give you energy drinks. You work on a thing that you come up with on the spot. It's like jazz for software. It's so cool. It's the coolest thing. I went to a bunch of hackathons, and like the best I ever did was I got second place at one. But I did one project at a hackathon. It wasn't my idea, but this guy, he was like a business major at UCLA, and he said, "Oh, my degree was worthless. I can't get a job. I'm learning software. Let's build this thing." And so we built this hack for Tinder, the dating app, it's like a man-in-the-middle attack where we had a fake profile and we had people talking to what they thought was that profile, but we would match people up to each other and have them talk to each other, and we would record the conversations, and there you go. And yeah,
So,
it was a good one.
So not being experienced in hackathons and in these days of COVID where we are all working from home.
Oh yeah, yeah. I don't think
being
hackathons
organized?
are happening.
Are they
I don't know. Right. So hackathons typically will happen like at some venue over a 24 to 36-hour period. You go, you show up, maybe with an idea, maybe not, and you build something from scratch. And that's the ethic, at least. That's like the ethos. That's what you're supposed to do. Some people show up with an already finished product, and that's not cool. I don't know if hackathons are happening right now. There are such things as code days and code jams and game jams. Those are slightly different because you don't necessarily have to go to a physical space for those things, and those are probably still happening. I should look that up.
I think those are happening still.
That's cool. I've actually, like, since graduating and working at Google, I actually have now mentored at a hackathon, you know, as a Google engineer, helping people out using Google Cloud. That was a whole, wow, the whole page has turned kind of thing for me.
I was trying to find some things that maybe we could get off the ground in these days of COVID.
Yeah.
as a 589 collective, we could think differently and dream big.
I think a virtual hackathon would absolutely be one of those things. That would definitely, you don't have to be in person to collaborate with software. You really don't. That's totally something that would work in these times. Absolutely. Set up a webcam and like a Zoom party and get coding, you know? And people like share their code with like USB files and stuff when they're in person. Just learn version control and you're good to go. You've already learned a skill, you know?
I have to jump off this because my work computer is shrieking at me, but thank you so much for talking today. I really enjoyed it.
Thanks for the great questions. Thanks for coming out.
Yeah, so we have gone over an hour, so I'll open up to one last question if anyone has anything. This is your last chance to ask Sam. It's not your last chance, really. The video will be up. I'll have it up much faster this time. My goal is by Friday this week. And of course, you know, you can leave questions on the video and I'll definitely get Sam over there to answer it if you have anything. We have lots more great talks coming up. Next week, we'll have a talk on Friday from Stephen Beck. He graduated in 2011. He's currently a tech sergeant in the Air Force, and he will be sharing stories about what the lessons he took from his short time on 589 and how he's used them in the Air Force. And so that's going to be a really good talk. He's currently in Germany, so 2 p.m. here Friday is going to be something like 11, 12 for him there. So definitely please tell more people from 589. We had a very good turnout, but I know we can do better. We're really planning around the time that works for the speakers. So just remind everyone, join when you can.
So is he a pilot or is he not a pilot?
He is not a pilot, which is extremely disappointing, but he can tell you about that next week. I've just kind of been rambling, but no one's spoken over me, so I'm assuming there's no more questions. So thank you, Sam. Do you have any last words?
Just keep putting in the effort. Whatever you're interested in, it'll always be worth it. Don't give up when you fail. Take that as a learning opportunity. Keep working on it. Even if you don't get into college, there's still a path for you. Just keep going.